All right, the next section that we're going to talk about is the right triangle trig. Okay, so everything that we're going to discuss in this next section is only applicable to right triangles. And does anybody recall the word used to describe triangles that are not right triangles? Mentioned it, didn't emphasize it a whole lot, but the word is oblique. Oblique means not right. Okay. And so it means it's either acute or obtuse. There's no way, it doesn't specify which, it just says that it's not a right figure. And it's used mostly in triangles and solids. Okay, but all of the things that we're going to talk about in this section will have to do with, or with this portion of the section, will have to do with right triangles. Okay, how many of you guys have been exposed to the right triangle trig stuff before? Sine, cosine, and tangent? Everybody in physics already has, right? And then some people in algebra classes often go through this as well. Okay, just really quickly, if it's something where you haven't been exposed to this, or the brief summary that I give isn't enough for you, either look it up online, there's plenty of information about it, or just check with me and I'll go through it in more detail with you. Okay. I haven't decided yet whether chapter 5 will be or not. I'll give you a heads up on it, though. Okay, and for this, the right triangle trig, how many of you have heard of the acronym SOH CAH TOA? Okay, so again, most of you, so that's good. If you're given a right triangle, okay, there's three sides in a right triangle. They're either going to be labeled legs or the hypotenuse. Okay, with respect to these, okay, if you're referring to an angle, and an angle might be referred to by using a capital letter, like angle A, it might be referred to by using a symbol, a Greek symbol like theta. Okay. When you're looking at, let's say, angle A, which is labeled theta here, with respect to this chosen angle, the legs will also be further classified based on their relative position to that given angle. So one leg is going to be opposite the given angle, and one leg is going to be adjacent to the given angle. The adjacent leg will be one of the sides of the angle. The opposite leg will not be either side. And now, if I had been referring to angle B in this case, then my leg AC would be the opposite leg, and leg BC would be my adjacent leg. So it might change. It all depends on how it's related. But when you set up your trig ratios, and there's three trig ratios that we're going to talk about, and those are sine, cosine, and tangent. And these terms simply refer to the ratios of parts of a right triangle. Okay, the sine of an angle simply refers to the ratio of its opposite side to the hypotenuse. So in a right triangle, the sine of an angle is equal to the ratio of opposite side to the hypotenuse. Okay, so if I was looking at, with respect to angle A here, let's call the sides, and the sides will usually be labeled with the lowercase letters of whatever angle is opposite it. So A, B, and C are opposite angles A, B, and C. So if I looked at this figure, the sine of A, anytime we abbreviate, or when we identify these, we're only going to identify them with the first three letters. Okay, please don't describe this or speak this as sin. Okay, so it just represents the sine of A. Okay, the sine of A is the ratio of the opposite side, A, over the hypotenuse, which is C. Okay, cosine, when you look at this acronym, cosine is equal to adjacent over hypotenuse. And so when you're looking at the cosine ratio of A, the cosine of A would be the adjacent side B over the hypotenuse C. And then finally the tangent is the ratio of the opposite over the adjacent side. So opposite side divided by the adjacent side. And so if I was asking you to identify the tangent of A, the tangent would be opposite A over adjacent B. Okay, so this same set of relationships would hold true for angle B. So if I was looking at the sine of B is opposite over hypotenuse, B over C. Cosine of B is adjacent over hypotenuse, A over C. And the tangent of B is opposite over adjacent, B over A. Okay, so here would be the way that these trig ratios are set up. Okay. Now when you look at these, there's numeric restrictions on the sine and cosines. Okay. Is it possible in a right triangle for a leg divided by the hypotenuse to be a number greater than 1? What's the longest side in a right triangle? Always the hypotenuse. So can the ratio for the sines or the cosines can never be greater than 1. So these ones must be a value between -1 and 1. The tangent, there's no restriction on that. A can be much longer than side B. Again, it's kind of unlimited. There's no specific restriction on that. But the sine and cosines have to be numbers that are less than 1, greater than -1. All right, we'll come back and I'll talk a little bit more about these. Again, hopefully you guys recall or have been exposed to this or recall the relationship. The next thing that I want to do is make sure that you guys know how to use your calculators for this. So if you can take out your calculator. If you don't have yours, you can open the one online. It's under the classroom folders. All right, the first thing to make sure of is you are in degree mode. So when you turn on your calculator, anytime you're doing a problem for this class, okay, check and make sure on your display right here at the bottom line, it says DEG. If it says RAD, you're going to get the wrong numbers. Okay? And if I give you a multiple choice test, the answers that you would get if you're in the wrong mode will always be one of the distractors. Okay, so make sure your calculator is set to the right mode or you will guarantee miss the problem, even though it seems like you got the right answer.
How do you set it to that mode?
If your calculator says RAD, what you need to do is hit this mode button. It's right below the white alpha key. Scroll down 3 spots to where it says angle and change that from radian to degree, okay, until you see that it says DEG. Now, if you use a calculator online, I'm not sure how the defaults are for that. I think it's defaulted to degree, but I'm not 100% certain. You're probably not going to use radians until you get into pre-calc or calculus.
How do you get to the one online?
The one online, if you go to the classroom folder, I think it's like a O drive or something. Is it U drive?
Yes.
Okay, so go to the U drive. So go to Explore. If you right-click on the Windows symbol, you can choose Explore, or the Windows symbol in the bottom left corner. or right-click on it. Open the folder one, Explorer. There you go. Okay, so under class drive, if you look under the classroom folders, and then department, or math, and then my name, and then TI emulator, open until the very last one, and it's the executable application file. It's like second to the bottom. It says VTI. And just choose run, and you'll pull up what I'm using too. Go ahead and hit. There you go. All right, so once you're in degree mode, there's two different cases of using this. You're either going to use it to find trig ratios or to find angles. And if you're finding trig ratios, what you're going to look to do is the following. And this is probably what you would most likely have done in the past. If you wanted to evaluate the trig ratio for the sine of 47, what it's asking you is, it's asking you to find what is the ratio of the opposite to hypotenuse, opposite side to hypotenuse, in any right triangle with a 47-degree angle. Okay. And so using your calculator for this winds up being pretty simple. All the trig ratios are along this first line of the letters here, the x, y, z, t line. And so if you hit second function y and type in 47, now if I don't put anything after this, if I just hit enter, I'm in exact mode, so it's not going to give me the decimal form. You'll usually evaluate trig ratios to 4 decimals. Okay, and I'll specifically tell you, usually with angles, you'll evaluate it to the nearest whole number. Okay, so if we're looking to evaluate this, we either need to hit the green diamond button. That guarantees that your answer is in decimal form. So here I get 0.7314, again rounding to that 4th decimal place. Or I could have also just put a decimal point in my answer, in my display, and that would give me my answer in decimal form as well. Okay, so choose one of those two things. Okay. Also, if you are using the calculators on the computer, you can adjust the size of it by putting your cursor along the side and just dragging it out, and you can make it larger so it fits more of your screen. Okay, so I want you just to really quickly, on your own, find the cosine of 47 degrees and the tangent of 47 degrees. Make sure that you can do those, please. It'll always be decimal. In pre-calc, you'll learn that cofunctions have complementary trig ratios. Right, so when you're looking at this, the cosine is second function z, 47. Again, oops. Hit the green diamond or a decimal, put it into the decimal form, 0.68. Now, when you look at this, the way that this one has to round, you can't put 19, because the 9 gets rounded to the next one up, which bumps everything. So what you would need to put for that problem would be 0.6820. And then finally the tangent, second function t, 47. Again, you could put a decimal if you'd rather do that than hit the green diamond key, 1.0724 if you round it to 4 decimals. Again, notice there's no restriction on tangents. It can extend from positive or from negative infinity to positive infinity. Okay, so what these are actually representing, so when you see something that says the sine of 47 equals 0.7314, what that's actually saying is if you take any right triangle and you measure off an angle of 47 degrees, it's telling you that the ratio of opposite to hypotenuse, that A over C has to be 0.7314. So you can find what that ratio is. You know that that has to be true in any triangle, right triangle with an angle of 47 degrees. And so that's where these calculations come from. Again, back when I was in school, these were one of those things that you just had a table in the back of the book that had all of them listed. So the fact that the calculators can give you these is a huge time saver. Okay, now the other thing that you will need to do with this is to identify a measure of an angle. Okay, so if that's the case, you're going to use what are called inverse functions. The inverse functions are located right along the same line. It's just the green diamond instead of the second function. And the inverse functions allow you to find what angle has a specific trig ratio. And the way that those will look is they'll have a power of -1. So it'll look like sine to the -1, but really what that's saying is inverse sine. So that's how I'll refer to it. So if it says the inverse sine of 0.9945, in order to evaluate this, again, you're just typing it in as it appears. So you take the green diamond y, the inverse sine of 0.9945, and when you do that, you get your angle, which you'll, again, usually you'll round to the nearest whole number. And so this one winds up being 84 degrees. Okay, I want you to see if you can evaluate the following as well. Okay, find to the nearest whole number what each of these trig ratios represent. Okay, so if we hit green diamond Z for inverse cosine, 0.9781, hit enter, you get approximately 12 degrees. And then finally, if we hit the inverse tangent, so green diamond T of 0.5317, hit enter, we get an angle of approximately 28 degrees. Okay, so again, what this is identifying is, it's saying that if you have a right triangle, and let's say here's angle x and angle, or side x and side y, and let's say this is the angle theta. What it's saying is, if the ratio of x over y is given as 0.9945, so with respect to this angle, that's if that ratio is given as 0.5317. So if you look at this information provided in this triangle, your angle relates to the given pieces of information as the opposite side and the adjacent side. Opposite and adjacent is which trig ratio? TOA, the tangent. So what it says is if this ratio of x to y is 0.5317, then theta has to be 28 degrees. So that's taking the inverse function to find an angle, tells you what angle has this particular trig ratio, and it identifies that value for you. Okay, so here's where you're going to see some problems involving these. So let's say I have this triangle. You all know what side AB is. What's that length? 5 is a 3, 4, 5 right triangle. What if I asked you, though, to find the measure of angle A and angle B? And I wanted you to find it to the nearest tenth.